Good morning everyone, my name is Oscar Arias Rubiano and I'm gonna talk about a paper developed by Paulo Alonso Gaona Garcia, Oscar Arias Rubiano, Julian Gonzalez, Carlos Montenegro Marin and Joaquin Sanchez Cifuentes, students and professors from Distrital University from Bogota and Santo Tomas University from Bogota. Some of our presentation is divided in some topics. First, the introduction, where we are going to introduce some concepts needed to understand our paper. Second, the objectives, where we develop some objectives planned to cover the development of our paper. Third, the work methodology. The work methodology is the steps that we use to complete our model. The fourth topic is the implementation, where we describe the tools used and the results obtained of our investigation. The fifth topic are the conclusions, and the sixth, the future work. The future work are the possible future projects that we are going to work through the development of this paper. For our introduction, we're gonna give a little definition about what is a Honeynet, what is a physiologic model, and the aspects to consider when using Honeynets to gather attacks information. These do the problems that we can encounter when we are making Honeynets, the vulnerabilities that we are exposed, and the aspects to be aware of to develop a good Honeynet and to gather information from this Honeynet in a correct way. The objectives that we planned was to introduce basic concepts about vulnerabilities and physiologic implementation. This is very important. To understand this paper, you need to have the concepts about what is a Honeynet, what is a physiologic, and how this is going to be implemented. The second objective is to design an attack prediction model through the implementation of Honeynets using physiologic rules to obtain results. This is the main objective of the paper. We're going to present a model that we generated to be able to predict some future. A Honeynet are information tools used to test security breaches on a network. The main purpose of a Honeynet is to receive attacks to identify vulnerabilities. The Honeynets are composed by honeypots. The honeypots are decoys that are used to gather attack information. It's the main objective of these honeypots to identify the attacks that are made on a network to identify vulnerabilities, and this way to establish a series of solutions for avoiding the penetration of these attacks on future events. Now we're going to talk about the physiology. Physiologic is a multivariate logic that allows to represent mathematically the uncertainty, providing formal tools for its treatment. We can see this in the image. The image shows the left side a non-physiologic model and the right side a physiologic model. We can see the difference between the curves. While in the left side there is a big jump, in the right side the curve is more soft. We can calculate the values through all the curve, while in the left side we can only calculate the values for the first input and the second input. Now I'm gonna be a little more specific about the methodology of work. The first step is to receive an attempt of attack on the Honeynet. After this, we identify this type of attack. Later, we classify the attack properties according to the OWASP rules. Here is where we begin with the implementation of the physiologic model. The input variables are going to be the kind of attacks made on our Honeynet, and the output variables, the outcome is going to be the analysis of the received attacks with probabilities of future occurrence. Now we're going to talk about the attack classification. The physiologic system generated is a prediction physiological system. This means that the physiologic system generated is going to work with probabilities and mathematical values. The second aspect is through some input values and generation of logic rules and output values calculated for each attack received. Each attack is going to be to have his own output, and the output is going to be a mathematical value that can be calculated for each one of these. Now, with the information collected, it's possible to predict the factors that generate vulnerabilities on our applications. we can predict if an attack is going to be more adequate than other attack, and we can predict the probability of occurrence. This way we can design strategies to try to design new methods to avoid the success of the attack in our Honeynet. Now we're gonna see a schema that shows how the input rules and the probability of occurrence give us the output. Now, the input rules are the technical impact, the ease of exploit, the intrusion detection, and the awareness. The output are the probability of occurrence from an XX attack, an injection SQL attack, or a broken authentication attack. The probability of occurrence according to the value that the output generates can be rated in high, medium, or low. This is going to be shown on the next slides. Now, these are the rule editor. The input rules are used with connectors and or according to the case. Semantic rules are used to define fuzzy logic rules based on the properties of proposed attacks. We can see the different kind of attacks and the different kind of vulnerabilities. Now, in the bottom part, we see the if clauses. If technical impact is severe and exploitability is easy and detectability is average and prevalence is common, then the XSS is a common probability, a low probability, or a high probability attack. According to these values, we can calculate the probability of an attack to occur. We can see the logic implied in this. If technical impact is moderate and exploitability is average and detectability is easy and prevalence is uncommon, we obtain a value for another kind of attack. These rules are the ones that give us the result of the probability model. Here are the results of the combination between the inputs and the rules, inference rules shown on the last slide. Here we can see each one of the vulnerabilities on the left side and the attacks, the output on the right side. We can see the probability of occurrence for each one of the attacks. Now, the values that present each one of the outputs attacks in the right side for the proposed values of each input variable, the properties in the left side. For proposed system attacks, the input values vary between 0 and 10. This is what I explained on previous slides. The input can vary between 0 and 10. Here we give the values of 5.26 to technical impact, 3.17 to exploitability, 3 to detectability, and 7.61 from prevalence. This is how our model functions, and we can obtain a numerical value for the probability of success and occurrence of one of these attacks. Conclusions. To finish the presentation, I'm gonna talk about the conclusions. Through OWASP rules, it's possible to represent mathematical analysis used to design a fuzzy logic model. We can give real values to the OWASP rules and to obtain a value that has a probability of occurrence that is real. This model can obtain data of attacks made on Honeynets to predict future attacks and detect security breaches. It's important to test this over Honeynets. Why? Because a Honeynet is a decoy, and we don't want to test this on production environments or on our network to protect, because it can generate security breaches. The output values for different logical rules won't be similar on maximum or minimum values. This happens because for each output different rules are generated. Always we are going to obtain an output value, a different output value. This is due because the logical rules are not similar between one or another value. If we want to obtain a different output, we must modify the inference rules. Now I'm gonna talk about the future work. We can continue working on this topic by designing an application that solves all the process of the model and can generate the information received on the Honeynet and show the output, the probability of the occurrence of the attacks. Thanks for your attention.